Welcome back to the training series for the Rehabilitation Cost Estimation tool for mining and exploration in New South Wales. This is Module 8. In this module, we will look at the Beneficiation Facility Input Sheet, which calculates costs for decommissioning and rehabilitation of equipment and infrastructure focused on adding value to the raw product or ore. Tables are available for heap leach pads, tanks and vessels, transfer and loading equipment including stackers, reclaimers, conveyors and ventilation fans, buildings, pipes, land rehabilitation including reshaping, sourcing and applying growth media and ameliorants and revegetation, maintenance and repairs of rehabilitated areas, and removal and disposal of waste and contaminated soil treatment. User build tables are available for heap leach pads. The key point of note for this sheet is that the first table in the tanks and vessels and pipes section has all the default rates for those items as well as sections that show them individually. This allows the flexibility to either just pick one tank type or show the specific tank types by inputting quantities into those tables. Let's go through an example. For each of these modules, we will retain the quantities we added during the previous modules so we can see how a cost for a mine or set of mines is built up. The default rate selections in the Beneficiation Facility sheet are simple to use, with most tables requiring only a single entry and a selection from a drop-down menu. As for all the sheets, there is significant flexibility in how we choose to enter quantities across the columns. For this example, we will specify individual components using several columns. We add the name of the area to the activity row and add notes to the next row to provide more context for the column. We will preserve the first two columns just for heap leach pads and will use a default value in the first and a user build in the second. The first heap leach pad is medium risk and has a footprint of 5 hectares. This is all that needs to be done for this column. The second heap leach pad is 10 hectares and we have good information on the cap design so we can decide to use the user build table. If the user build table is not visible, click the show box in the filter here. We will enter the name as Heap Leach Pad North and some notes to assist our review and inform the regulator. We must select a risk level as this automatically populates the default capping thickness reference from the Assumptions capping sheet. We will select a high risk level. We enter a GIS reference if available, and then the footprint area of the heap leach pad, which is 10 hectares, then the area of the ramps, which is 1 hectare. If these are the only quantities entered, the calculation will use all the defaults. However, for this example, we will demonstrate the flexibility of the user build table by entering site-specific quantities in some areas. We will accept the defaults for the ramps except for the fleet and one-way distance for load and haul of rock to stabilize the ramps, which we change to 1,500 to 2,000 meters as our rock is sourced from 1,800 meters away. The volume of rock required is calculated by the tool. For the subsequent capping sections, the area suggested is the footprint area entered at the beginning of this table, which we can override for each area. For example, if half of the heap leach pad is already capped, we can change the 10 hectares to 5 and make a note to inform the regulator. Generally, heap leach pads do not require a working layer and the default thickness is set to 0, meaning the cost for this section is 0. If the site-specific case has a working layer, we can enter the area and thickness. For this example, we are assuming the capillary break layer of the heap leach pad must be thicker due to a specific characteristic of the structure. We accept the defaults but enter the site-specific thickness, in this case 0.4 meters. The tool then uses the user-entered number to calculate the volume. The low permeability layers are typically clay, and we need to select whether the clay is coming from a borrow pit on-site or off-site for the tool to calculate the cost. For this example, we are assuming there is no suitable material on-site and all must be procured from an off-site source. However, we have a quote from a supplier for a rate that is lower than the default rate, so we enter that and provide a justification to the regulator in the notes section. Our rate includes transport and delivery on-site. Consequently, we set the trucking rate in the alternate rate box to 0 and provide a further note to the regulator. We will leave the other rates and defaults for low permeability layers as suggested by the tool and move down to the next section. We will accept all the suggestions and defaults for the top rock layer. In most cases, it is envisaged that additional capping will not be required. However, it is easy to add quantities if additional geolayers must be added. For drains and water management, the suggested area is 10% of the footprint area. For this example, we are assuming drainage is particularly troublesome and will increase the area requiring drainage and water management to 2 hectares. Further, we will select drains of 8 meters width. As for drainage tables throughout the tool, there are several options available, and we will select the one most applicable to our structure. For the land rehabilitation tables, the area suggested is the footprint area plus the area of the ramps entered by the user at the top of the table. We will accept the suggested area for this example, but assume the natural pre-mining condition had minimal growth media and enter 0.05 meters for the thickness. We tell the tool whether the growth media is coming from on-site or off-site or a combination of both. In our example, minimal growth media is required and it will all be coming from on-site. So we enter the same volume calculated for growth media to the row for on-site supply. We don't then need to enter any quantities for the off-site component. The last table is for spreading, which includes a component for load and haul of the locally sourced growth media. In our case, the growth media is adjacent to the structure, so we select the less than 200 meters category. For this example, we will add gypsum to the growth medium mix to correct staticity issues, but we have a delivered on-site rate quoted from a supplier for $100. So we set the rate to 100 and the transport cost to 0 and add notes for the regulator. For the vegetation table, we accept the area suggested by the tool and select pasture for all the selections. The last tables are for permeability testing and engineering, and we will accept the defaults. The cost estimate for the user build heap leach pad is now complete. We will now move to the third column and enter quantities associated with a processing area dense with tanks and piping. To begin with, we will enter the name as Blending Area A. This area includes 2 5,000-ton silos, which we will add to the first row of the tanks table. Next, we'll include 3 1,250-ton silos, followed by 4 100-kiloliter thickening tanks and 2 10,000-liter thickening tanks. Finally, we'll note 1,000 meters of 200mm diameter above ground connecting pipe linking these tanks. Similarly to the tanks table, the first row of the piping table has all the pipe selections and the subsequent tables have the individual selections. In our example, we have 500 meters of larger diameter pipe, so we add it to the last section here. The land rehabilitation associated with the tanks and piping is not included in the individual default rates, so we must add allowances. Our entire blending area is assumed to be 2 hectares. We must reshape the land, so we enter 2 hectares here and then 2 hectares to Area 1 for growth media, ameliorants with gypsum selected, and pasture revegetation. In our example, we have some old asbestos pipe, so we will add that to the waste disposal section, selecting asbestos pipe and entering our length of 200 meters. The tool converts the length to a mass using the conversion shown in the General Assumptions table. However, we can enter a specific mass if it is known. Like with other tables involving transport of materials, we select the one-way distance to the waste disposal point, which in our case is 30 kilometers. We then tell the tool whether a levy is applicable, and in our example, a standard levy from regional locations is applicable, so we select that option. We will now use the next column to show quantities for a loading area where we have 2 stackers, 1,000 meters of rail associated with the stacker, and 500 meters of overhead conveyor. If we wanted to add on-ground conveyors or other conveyor types in addition to the overhead conveyor, we would need to use separate columns. In this example, we also have a crusher and add that here. If we have other buildings, we would need to again use separate columns. The land rehabilitation associated with the stackers, conveyor, and crusher is not included in the individual default rates, so we must add allowances. Our entire area is assumed to be 10 hectares. We must reshape the land, so we enter 10 hectares here, and then 10 hectares to Area 1 for the growth media, ameliorants with gypsum, and pasture revegetation. For our last column in this example, we have an area containing some old, buried fuel tanks and contaminated soil associated with the dispensing of fuel. Our two tanks are 10 kiloliters, so we add 2 here, and the amount of contaminated soil is 1,000 cubic meters, which we add here. As described in the user manual, the biopile calculation has a minimum cost to reflect the base cost associated with building the pile. The threshold volume is shown in the assumptions general sheet. If we enter less than or equal to the threshold volume, currently 50 cubic meters, the cost will be a lump sum as shown. If we enter greater than the threshold volume, the calculation multiplies the quantity by the dollars per cubic meter rate. You can see if we enter 51 cubic meters, the tool shows the unit rate. It shows the same unit rate when we enter our 1,000 cubic meters. As for all the sheets, the subtotals for each table are shown in the black lines at the end of each section, and then the total for each column is shown at the top of the sheet. The total for the sheet is shown on the left-hand side, and then above that is the total for the entire RCE, so we can see in real time how quantities entered to the local sheet affect the total RCE. Let's jump over to the RCE summary to see how the total is building up. As we can see, we now have rolled up costs for infrastructure mine entries, infrastructure, and beneficiation facilities.